The Question of the Immovable Object and the Unstoppable Force by Ibn Sebastian with a lot of help from in physics. An immovable object. We note several equations about net force, mass, and acceleration. Force is equal to mass times acceleration, acceleration is equal to force divided by mass, and mass is equal to force divided by acceleration. An interesting question that we can ask is what does happen when an immovable object meets an unstoppable force? We can use the equations listed above in order to deduce several characteristics about this immovable object. In reality, an object cannot be immovable, since it can be seen as moving when you move relative to it. For example, riding a bicycle past a rock and seeing the rock move. However, an immovable object can be understood as an object that cannot be accelerated, no matter how much force is applied to it, as its mass is infinite. Its acceleration, therefore, is also 0 meters per second squared, as no amount of force is capable of altering its velocity. This doesn't necessarily mean that the said object is at rest. It can be moving at a constant velocity, but that velocity cannot be changed. The unstoppable force. By nature, all the four fundamental forces of the universe, electromagnetism, the weak and the strong force, and gravity, are unstoppable, as these forces are caused by interaction between force carriers, for example, photons and light. This continuously alters the momentum of whatever object they act upon. An unstoppable force, in this context, can be seen as a force whose velocity cannot be changed, which makes it pretty much the same thing as an immovable object. Since an unstoppable force and an immovable object are really the same thing, then what happens when they collide? We already know that their velocities and accelerations cannot be changed, so the only allowable action that is allowed to happen is that they pass right through each other. For the visually inclined, you can see a picture of what this means. So to the left, we have the immovable object itself. We already know that the object cannot be moved as its mass is infinite. No amount of force is capable of moving it. Since the mass is infinite and no amount of force can move it, its acceleration is equal to 0 meters per second. However, this does not mean that the object is at rest. It can be moving at a constant velocity. However, this velocity can never be changed. To the right, we have the unstoppable force. This unstoppable force cannot be stopped, nor its velocity be altered as well as its acceleration. Therefore, the unstoppable force is more or less the same as the immovable object. Both are moving at a constant velocity, and both are unacceleratable, meaning that their accelerations can never be altered or modified. What happens if these two were to collide? Since both of these objects, or rather the force in the object itself, are unacceleratable, the only action that can occur if they were to collide is to pass right through each other. We see the force approaching from the left and moving to the right, and we see the object itself moving from the right to the left. And as we see them collide, we see that nothing happens to their velocities or accelerations, but rather they just simply pass through. An even better explanation is provided by Henry Reich of Minute Physics.
What happens if an immovable object meets an unstoppable force is a popular question on the internet. Of course, relativity clearly tells us that there is no such thing as an immovable object. Here's why. If you pick any supposedly immovable object, or just something like your house or the earth, I can make it move. All I need to do is start moving relative to it. For example, I might ride a rocket, and suddenly from my perspective, I'm not moving and the earth sails by outside. The laws of physics make no preference for inertial frame of reference, so from my perspective here, I do not stir, and yet it's clear. The immovable object moves. So because of relativity, immovable objects cannot be. But what I think people normally mean by immovable object is something that if it's not moving, you can't make it start moving by pushing on it. So not an immovable object, but an unacceleratable one. Using Newton's second law, we know that an object's acceleration is equal to the total force on it divided by its mass. Though you've probably seen this as F equals ma. So an unacceleratable object would be an object with infinite mass. An object so massive that no matter how big the total force F is, when you divide F by m, you always get 0. Of course, as we've said, not being able to accelerate an object doesn't necessarily mean that the object isn't moving. It just means that you can't directly change its speed. If it's not moving, then it'll stay not moving. And if it's moving at 100 miles an hour, then it'll stay moving at 100 miles an hour. So, what about an unstoppable force? Well, all the fundamental forces in nature are actually caused by particles, like photons or gluons or gravitons, that interact with an object and change its momentum. The only way to not be affected by a force is to not interact with it at all, like how electrons don't interact with gluons so they aren't subject to the strong nuclear force. Even light itself is an unstoppable force. Every photon that hits your body changes your momentum a tiny little bit, and there's nothing you can do about it other than avoid light altogether or become transparent. So all forces are already unstoppable. But my impression is that the phrase unstoppable force isn't really meant to imply anything about forces like electromagnetism or gravity, but rather something that you cannot stop from barreling down on you. That is, an object whose velocity cannot be changed by pushing on it. So if by an unstoppable force we mean an object moving at a speed that can never be changed, then that means the object cannot accelerate. But wait a second, this sounds familiar. Recalling what we learned earlier, an unstoppable force must be an unaccelerable object. And that means that an unstoppable force and an immovable object are really just the same, viewed from different reference frames. Now, since infinite mass requires infinite energy, we don't know of anything in the universe that behaves like this. Not the least because it would automatically be a black hole so big that everything in the universe would already be inside of it. But what if we ignored gravity and imagined there were an unaccelerable object? Well, first it would be an infinite source of free power and would allow us to live in a 100% happy utopian society and break the second law of thermodynamics and probably create portals and time travel too. You can do a lot with infinite energy. But more importantly, if two of these infinitely massive unacceleratable objects were moving towards each other and collided, then since by definition it's not possible for the velocity of either of them to change, the only possibility is that they must pass right through each other with no effect on each other at all.
And these are the credits. Thank you for watching my podcast.